Hi, it's Mr. Anderson, and this is AP Physics Essentials Video 1. It's on objects and systems. If we were to take something like a tennis ball, could you figure out if it's an object or a system? The right answer is yes. It's both an object and a system, and it depends on what question we're trying to answer. So if that tennis ball is a projectile and we're studying projectile motion, the internal structure of the tennis ball is not relevant to the question we're trying to solve. We're just angling the shot of the tennis ball and figuring out how far it goes. And so we can treat the tennis ball as a single object. However, if we were to look at the synthetic rubber that makes up the tennis ball and how its elasticity changes at different temperatures, then it's more important to treat that as a system made up of a bunch of atoms, and understanding how those atoms behave at different temperatures would be relevant to the problem that we're trying to solve. And so a system is made up of two or more objects that are connected together in some way. Now, if the internal structure of that overall system is not important, we can just treat that whole system as an object. And so what is an object? It's anything that has no internal structure or no relevant internal structure. Now, you might think as we look smaller and smaller in the world of physics, as we get down to the level of atoms, then everything must be an object. But what scientists have discovered is if you break down atoms, we get particles inside those small particles. Those are electrons, protons, and neutrons. Some of these are what are called fundamental and some are not. So an electron is a fundamental particle. What does that mean? You can't break down an electron into other parts, at least no parts that we've discovered yet. And so we treat it as a fundamental particle, a single object. Protons and neutrons are actually made up of other fundamental particles. And so a proton is made up of two up quarks and one down quark. And a neutron is made up of two down quarks and one up quark. And depending on the question that we're trying to answer, these parts inside those protons and neutrons may be relevant to the problem we're trying to solve. For example, the charge of a proton and neutron comes from its constituent parts. And so in physics, we're going to study matter through space and time at all these different levels. And so since we're studying matter, it's important that we understand a base unit on what matter is made up of. And when we're solving problems, you have to understand what's an object and what's a system. And so in other words, this hot air balloon could be treated as an object if we're looking at buoyancy, but if we're studying the kinetic energy of the molecules, we have to treat it as a system. And so a system is a collection of different objects. And so this Atwood machine here is made of two weights, and then it's made up of a pulley. And so we can treat that as a system. And each of those weights is treated as an individual object. But if we were to zoom into that one weight, that also can act as a system. It's made up of mostly iron atoms, and that iron atom in turn is made up of subatomic particles, electrons, protons, and neutrons. And if we break those protons and neutrons apart, we find quarks on the inside of that. And so understanding all the parts, depending on what question we're trying to answer, may become important. So let's talk about charge, for example. And so here are three fundamental particles. We've got an up quark, a down quark, and an electron, which is also a fundamental particle. And so if we want to figure out where the charge of a proton, for example, comes from, we could look at the charge of each of these quarks. The charge of an up quark is 2/3 the charge of an electron. And so it's 2/3 positive charge. A down is negative 1/3 charge of an electron. So if we want to figure out the overall charge of a proton, what do? Well, let's add up the charge of those two up quarks. So that's 2/3 plus 2/3 or 4/3. And then we have to subtract the 1/3 of the down quark. And so if we subtract 1/3 from 4/3, we get 3/3 or a positive 1 charge of a proton. If we're looking at the neutron, for example, that's 1 up, which is going to be 1 2/3 charge, positive charge, minus 2 1/3 down charges, and so that's why a neutron has no charge. And so if we're trying to figure out the charge of these particles, then the fundamental particles become important. And so did you learn the difference between a system and an object? Again, it depends on what question we're trying to answer. Are the parts of the tennis ball important? If so, then we must treat it as a system. If not, we can treat it as an object, and I hope that was helpful.